Hello students, before starting the chapter, the new chapter, I would like to clear some doubts regarding the chapter physical and chemical changes. One of you asked, I have seen the comments, one of you have asked that what is molybdenum? What is molybdenum? Molybdenum is a promoter. It's not a catalyst. It can enhance the capacity of a catalyst, and the full form of this metal MO is molybdenum. MO means molybdenum. Then the next question was that regarding this same chapter, next question was where this arsenic oxide and mercuric salt, mercuric or mercurous salt, the Hg salts are used. What are the uses of these salts? These salts are taken as inhibitor or the negative catalyst. Negative catalyst means which can decrease, which can inhibit the rate of a reaction. If these compounds are present in a chemical reaction, the rate of the chemical reaction will be decreased. Next question was that double decomposition reaction. Double decomposition reaction means two types decomposition. That's why double. If two salts individually will have one cation, one anion, two salts will react together to form another two salts. There will be interchanging or exchanging of anionic part. So individually they will undergo two times decomposition and they will combine again to form two new compounds. Now I'm going to start a new chapter, that is atomic structure and chemical bonding. We have learned about this atomic structure in class 8 also. So let's recall. The new thing is chemical bonding. So let's recall this atomic structure once. John Dalton's atomic theory. First, the atomic theory was proposed by Sir John Dalton. He said that matter consists of small and indivisible particles called atoms. That means atoms are the smallest particle, the tiny particles of a matter. And atoms are neither be created nor be destroyed. Atoms are combining together to form a molecule. The atom is the smallest unit of matter which takes part in a chemical reaction, and all chemical changes result from separation or combination of atoms. Now, according to modern atomic theory, there are some contradiction between these two theories, Dalton's atomic theory and modern atomic theory. John Dalton said that atoms are indivisible, but according to modern atomic theory, atoms can be divided into three subatomic particles. They are electrons, protons, and neutrons. Electron is a negatively charged particle. Mass is 9.1 into 10 to the power 31 kg. Charge 1 minus, it is because it is negatively charged particle, minus 1.6 into 10 to the power minus 19 coulomb. And proton is a positively charged particle, mass 1.672 into 10 to the power minus 27 kg. You can see the difference of mass of an electron and a proton. The mass of proton is much more greater than the mass of an electron. Charge of proton is same, only the electrons will have the negatively charged and protons are positively charged. The amount is same, 1.6 into 10 to the power minus 19 coulomb. Next, structure of atom. I have drawn the structure of an atom. This is quite similar with the solar system. With our solar system, what happens in solar system? Sun is the middle part. That means all the planets are revolving around the sun. Like this. In case of atom also, this is the central part. Central part is known as nucleus, and these are the orbits or cells. These are the parts where the electrons are revolving with very high speed around this nucleus. Inside the nucleus there are protons and neutrons. Inside the nucleus there are protons and neutrons. Protons are positively charged particle, and neutrons another subatomic particle which is which is not having any charge, is a neutral one. And these are electrons. Electrons are revolving around the nucleus. The speed of an electron is 1/10 of the speed of the light. We know the speed of the light is 3 into 10 to the power 8 meter per second. Now, what is atomic number? Atomic number is abbreviated by Z. It is the number of proton or number of electron. Number of proton or number of electron. Atomic mass, which is known as mass number also, abbreviated as capital A. This is number of proton plus number of neutron. That means P plus N. So we from these values we can calculate the number of neutron. We can calculate the number of neutron by subtracting this mass number and atomic number. Mass number we know P plus N, atomic number P, and PP will be cancelled out. This is the neutron. Let us take one example, calcium 2040. 40 is a mass number, 20 is the atomic number. Generally, the lower one, the smallest one will be the atomic number and higher one will be the mass number. So from here we can calculate the number of electrons present, number of protons present. So here number of electron 20, number of proton also 20, and number of neutron, how will you get? By subtracting this mass number and atomic number. So 40 minus 20, 20 will be the number of neutron. Next, electronic configuration. What is electronic configuration? Electronic configuration means arrangement of the electrons in different orbits or different cells. Before this, I forgot one thing to say, that these orbits are having different energies. These, the smaller one, the inner one, are having the lower energy, and outer one will have the higher energy. When an electron will gain energy, it will jump from the lower energy to higher energy, and when it will lose energy, it will jump from the higher energy level to the lower energy level. Now I said, what is electronic configuration? Electronic configuration is the arrangement of the electrons in different cells, in different orbits. So there is a rule, that is 2n square rule, where n is any integer 1, 2, 3 and so on. When n equals to 1, by putting the value of n 1, we will get 2 into 1 square equals to 2. So maximum in the first orbit, which is known as K shell, maximum 2 electron can exist. Now when n equals to 2, 2 into 2 square, that is 8. For the second orbit, which is known as L shell, maximum 8 electrons can exist. For n equals to 3, 2 into 3 square, 18. So for the third cell, which is known as M cell, maximum electrons are 18. And for n equals to 4, maximum number of electron will be 32. Now, it will be more clear if we will take one example. Here I have written magnesium 2412. 12 is the atomic number, 24 is the mass number. So from here we can get number of proton 12, number of electron 12, number of neutron. By subtracting these two, we will get 24 minus 12, 12. Now what will be the electronic configuration? K cell I said maximum 2, L cell maximum 8, and remaining electrons we will put in the next cell. So this is the outermost cell, because we don't have any electrons to put over here. So first 2, second cell 8, third cell 2. So this is the orbital structure diagram of the magnesium atom. Here inside the nucleus, proton 12, neutron 12. This is the first cell. K cell contains 2 electrons. This is the L cell, contains 8 electrons, and this is the last cell, M cell, contains 2 electrons. Next one, valency. What is valency? This is the combining capacity of an atom. By how many, with how many atoms it can combine, that is its valency. What are the valence electrons? Number of electrons present in the outermost last cell. That means this is the last cell. If we consider this atom, this Mg1, this is the last cell. Last cell is known as outermost cell, and the electrons present in the outermost cell are known as valence cell electrons. And before the last cell, this cell is known as, just before the last cell, the cell is known as penultimate cell. What is the name? Penultimate cell. Now, valency equals to, how to calculate valency from electronic configuration? Valency equals to number of valence electrons if it is less than 5. Mind it, valency will be number of valence electrons if it is less than 5. If it is equal to or greater than 5, then we have to deduct 8 from the number of valence electrons. Now it will be clear if we will do this calculations by taking this example. Aluminium 1327, 13 is the atomic number, 27 is the mass number. So we will get proton equals to 13, electron equals to 13, neutron will be 27 minus 13, that is 14. Electronic configuration, first cell 2, second cell 8 and third cell 3. So valency we can write directly 3, because I said valency will be the number of electrons present in the outermost or last cell. But in case of sulfur, sulfur 3216, mass number 32, atomic number 16, proton will be 16, electron will be 16, neutron will be 32 minus 16, 16. So electronic configuration will be KLM 286. In the first cell it will be 2, in the second cell it will be 8, and third cell it will be 6. So valency will be 6 minus it. Why? I said if the outermost cell will contain more than 5, equal to 5 or more than 5, we have to deduct 8 from this number. So 6 minus 8 minus 2. Valency is coming minus 2. You can practice the following problem. Find out the number of proton, electron, neutron, electronic configuration and valency of the following atoms. Boron 11.5, nitrogen 14.7, fluorine 19.9, silicon 28.14, chlorine 35.17, potassium 39.19, and this phosphorus 31.15. But for calcium 40.20, one thing is there, that is here proton 20, electron 20, neutron 20, electronic configuration 2882. Why I have written in this KLM shell? In M cell it should be 18, so we can write total 10 electrons, but instead of writing total 10 electrons, we are dividing these 10 electrons into two parts, 1 8 and 1 2, and these 2 electrons are transferred to the next cell. Why? Because for this we have two rules, octet rule and duplet rule. If the last cell contains 8 electrons and if the last cell contains 2 electrons, that will be its most stable configuration. To attain this stability, we have put the electrons in the next cell. Next one, isotopes. Isotopes are the elements of same atomic number and different mass number. Same atomic number but different mass number. You can see over here Cl3517, Cl3717. Here 1717. Their atomic numbers are same but their mass number, one is 35, one is 37. Due to their different mass numbers, their number of neutrons also different. Neutron over here 35 minus 17 18, over here 37 minus 17 20. Isotopes have similar chemical properties but different physical properties. Why? Because we know chemical properties depend on the valency, and valency we can get from the electronic configuration. As their atomic numbers are same, their electronic configuration will be same. That's why their chemical properties will be same. But due to their different mass number, due to their different atomic masses, they will have the different physical properties. What are isobars? Isobars means the elements which are having same mass number but different atomic number. I have taken the example of argon and calcium. Argon 1840, calcium 2040. You can see the mass numbers are same, but their atomic numbers, one is 18, one is 20. So they will be isobars to each other. They have similar physical properties but different chemical properties. As their number of protons or electrons, their atomic numbers are different, their electronic configuration will be different, their valencies will be different. For that, they will have the same physical properties but different chemical properties. That's all for today. Next day I will explain the next part, new part, chemical bonding. Thank you.